Welcome back. As part of AWS EKS Load Balancer Controller, Kubernetes Ingress, Application Load Balancer, and also external DNS. So considering all these four things, we are going to implement 14 demos. If you see here, as part of demo 1, we are going to install the AWS Load Balancer Controller. And after that, we will learn the Ingress basics as part of demo 2. And later, we will implement the Ingress context path based routing as part of demo 3. And later, we will implement the Ingress SSL and Ingress SSL redirect as part of demo 4 and demo 5. So considering all these demos will be related to application load balancer, which means every demo, whatever we are creating, we are going to implement these things using Kubernetes manifest on AWS application load balancer. And we are also going to install external DNS using demo 6. And later, we will implement Ingress plus external DNS and Kubernetes service plus external DNS as part of demo 7 and demo 8. Ingress plus external DNS in the sense, so whenever we deploy our Ingress manifest, automatically the DNS registration happens in the AWS Route 53, whatever the DNS names defined in the Ingress manifest. So that we are going to learn as part of demo 7. And as part of demo 8, not only with Ingress, with regular Kubernetes service, which is of type load balancer or node port services. So there also Ingress external DNS related annotations can be added to DNS register those service related DNS names inside the Route 53. So which means the Kubernetes service inside that you can add the external DNS annotation for your application, and that DNS name using external DNS can be DNS registered in the AWS Route 53. So both demos, Ingress plus external DNS and Kubernetes service plus external DNS, we are going to implement. After that, we are also going to implement Ingress name-based virtual host routing. So we already implemented Ingress context path based routing. So which is nothing but when the request comes to /app1, go to app1. Whenever the request comes to /app2, go to app2 related backend. So those are context path based routings. So name based virtual host routing is nothing but whenever you access your application with app1.somedomain.com, go to that respective app1 related backends. And when you access with app2.somedomain.com, the request should go to app2. So even that example we are going to implement using Kubernetes Ingress manifest, and equivalent ALB rules will be created. And after that, we are also going to implement SSL discovery host and SSL discovery TLS. So without hard coding the AWS certificate manager, certificate ARN in your Ingress, so you can use the options like SSL discovery host and SSL discovery TLS. So those things also we are going to learn in detail with practical demos. And after that, we are going to implement Ingress groups. So with Ingress groups, the large configuration of Kubernetes Ingress manifest can be split into small Kubernetes manifests, and we can create multiple Ingress resources and combine them to a single group with a priority order. So we are going to learn that in detail as part of demo 12. And after that, we are also going to learn about Ingress target types, which is instance mode and then IP mode. So far, whatever the demos we have implemented is default is going to be instance mode, and we implemented it with instance mode. So here, as part of demo 13, we are going to learn about IP mode and implement that with IP mode. And finally, we are also going to implement the Ingress internal ALB. And to test that, we are also going to deploy a curl pod and connect to curl pod and test it. So let's go ahead and then practically implement all these things now. So I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. In this section, we are going to understand about ALB Ingress controller on a very high level. So before going to ALB Ingress controller, we are going to look into AWS application load balancer. So let's see what is application load balancer and then what it supports, and how this application load balancer can be created from Kubernetes manifest using ALB Ingress manifest using ALB Ingress controller. So we are going to see all those things in our this respective section. Okay, so let's move on with what is application load balancer in AWS, right? So ALB is a super advanced next generation load balancer in AWS. So it supports tons of features. Let's see what are those to get a high level idea on how much it is capable of. Okay, so it supports path-based routing, which is nothing but context path-based routing for our applications. So single load balancer can be leveraged for using for multiple applications hosted on AWS based on context paths. Okay, in the same way, it supports host-based routing. So which means in addition to context path-based routing, we can deploy multiple applications and then using different host names, we can route to those respective applications back of this load balancer. Example, apps.kubencloud.com will go to applications, okay, and users.kubencloud.com can go to user management REST services. So something like that. Okay, and next is support for routing based on fields inside the request, like HTTP headers, HTTP methods, query parameters, and source IP addresses. So by seeing these three features itself, we can understand that it's not only a load balancer, it is also a routing solution on the HTTP level. Okay, and supports for redirecting request from one URL to another. So more or less standard Apache web server or Nginx related features it has. Okay, supporting for returning a custom HTTP response to, and supporting for registering Lambda functions as targets. So anything deployed in AWS, one service always integrates with multiple other services. In the same way, multiple Lambda functions also we can register them to this respective load balancer targets. In the same way, it supports for load balancers to authenticate users of our applications through their corporate or social identities before routing requests. So this is the latest feature available, and then it is for providing the out-of-box authentication for our applications hosted on this respective load balancer with our corporate or social identities. So it also supports containerized applications, mainly AWS EKS out-of-the-box integrated with this respective application load balancer. It also supports monitoring the health of each service independently, as health checks are defined at the target group level. Okay, so that is also one important feature. It supports registering targets by IP addresses. So due to this support, we are able to leverage this very effectively in Fargate with EKS. Okay, so because of this respective feature. Okay, and it inside VPC or outside VPC also it can do this stuff. Okay, using the IP address. And all in all, ALB is latest and greatest load balancer with many good features. So this is about what application load balancer is capable of and what it can do. So now, if this type of load balancers, if we can use it as a ingress service for us from Kubernetes, so we are going to have a leverage of all these features for our applications hosted on Kubernetes. So that's the beauty of AWS here. Okay, so which means like AWS application load balancer can be provisioned for our Kubernetes using Kubernetes Ingress manifest. Okay, so let's move on. So let's see what is this ALB IC. ALB IC is nothing but ALB Ingress controller, right? So ALB IC triggers the creation of an application load balancer and the necessary support AWS resources whenever an Ingress resource is created in the EKS cluster. Okay, with the annotation name kubernetes.io ingress.class is equal to ALB. Okay, so the ALB Ingress controller supports two traffic modes, instance mode and then IP mode. We also seen that application load balancer supports both the traffic modes, instance and IP. So the same things are available in ALB Ingress controller also. Okay, let's see what are those in detail. And so this is one more documentation link for this ALB Ingress controller. So you can review this link and then understand annotations inside that and everything whenever you are going through it. And when you are going in the advanced sections, you will understand more and then more about it. Okay, so now let's see the instance mode. So in instance mode, Ingress controller registers nodes within your cluster as targets for the ALB. So which is nothing but nodes are nothing but our worker nodes in our EKS cluster will be registered to the targets inside the application load balancer. So traffic reaching the ALB is routed to node port for your service and the proxy to the prods. So which means like whatever the node port services we are going to create in front of our applications, means like in front of our application deployments. So first ALB routes to those node port services, and that node port service is routing to our pods. Okay, so this is the default traffic mode available in our ALB Ingress manifest. Okay, and you really don't need to define or specify that implement instance mode. By default it is applicable for us, but we can also explicitly specify it like this with target type as instance annotation in our Ingress manifest if we want it. And we have the IP mode. So in IP mode, it register pods as targets for the ALB. Here if you see, it registered the EKS worker nodes as targets for our ALB target types. Okay, but here it registers the pods as targets for the ALB. So traffic reaching the ALB is directly routed to our pods for our service. So now here if you want to use IP, then you can use the target type as IP. So now why these two instance modes and then how it is useful for us from AWS EKS perspective, that's the core thing here, right? So when you are using worker nodes, means like managed node groups in your EKS cluster, by default you can use instance mode, or if you want to use IP mode, still you have an option of using the IP mode. But when you are using only Fargate only profile, which means in your cluster you really don't have any other node groups, managed node groups like EC2 instances, you are just only using Fargate profiles. At that point of time, you need to use and if you want to use application load balancer, then you need to use only IP mode. Why? Because Fargate nodes doesn't support the node port service. Why? Because we really don't have control on Fargate related nodes, whatever it has created in the background, because that is a serverless concept, right? So that's about the reason you need to use IP mode. So whenever you are using Fargate, for those things, if you need Ingress manifest, you can use IP mode. And whenever you are using managed node groups, you can use either instance mode or IP mode. So that's about these traffic modes. So now moving on, so let's see how ALB Ingress works. So this diagram I directly took it from their website, and we will see what it is and then from step-by-step process how it looks like, and the link for this diagram is available here in detail. Okay, so now you see this is a Kubernetes cluster. Okay, and these are AWS resources. So we already said that whenever we provision our Ingress manifest on the Kubernetes cluster, it is going to create a AWS resources. So what are those AWS resources is what we are going to see now, right? So in the step 1, the controller watches for, which is nothing but the Kubernetes controller watches for Ingress events from API server, and when it finds Ingress resources that satisfies the requirements, it begins the creation of these AWS resources. So what are those AWS resources? You can see number 2, which is application load balancer. So application load balancer is created in AWS for the new Ingress resource provisioned in the Kubernetes cluster. Okay, but one thing here is this application load balancer will have a version of ELB v2. Okay, so whenever you see, we have two types of resources in Elastic load balancers in AWS, and this application load balancer, whatever it is getting created, is ELB v2. So that's one important note you need to remember. Okay, why? Because whenever you are giving IAM permissions and all those stuff, you need to ensure that ELB v2 also included in those stuff. Okay, and the next thing is target groups. Okay, so now the point number 3 is target groups are created in AWS for each unique Kubernetes service described in Ingress resource. Okay, so whatever the application related node port services you have defined in your manifest, so those related stuff has been created, and with that including those node port services, it is also going to create whatever the pods you have defined also, right? So now another important thing in your Ingress manifest is listeners, right? So whatever the listeners you specify for your application load balancer, those gets created here, which is 80 or 443, whatever you define. So those listeners also will get created in your application load balancer. So finally, rules, right? So as we said that application load balancer supports context path based routing. So which is nothing but /star/product/accounts. Okay. So /star should go to one target group, /product should go to one target group, and then /account should go to one target group. So all these things are supported in our respective application load balancer, which we are provisioning you as a Kubernetes manifest. Okay. So now another thing here is like if you want to delete, right? So if you want to delete all these things, just delete our Kubernetes Ingress manifest here, means like Ingress resource, whatever we have provisioned, delete it, and then all these things will get deleted. So that's about the Ingress on a very high level. Welcome back. As part of this section, we are going to install the AWS Load Balancer controller on AWS EKS cluster. And this is the core controller which helps us in creating the Ingress services in Kubernetes cluster. So let's understand more about this in detail. So from Kubernetes Ingress perspective, earlier AWS used to have AWS ALB Ingress controller, and that is renamed and redesigned now as AWS Load Balancer controller. And earlier it used to create only AWS application load balancer related resources on AWS from EKS cluster. So when you deploy a Ingress manifest, then it used to create a application load balancer on AWS. But now, as part of this AWS load balancer controller, it can create AWS application load balancers and network load balancers. So for creating the application load balancers, we are going to use the Kubernetes object named Ingress resource. And for creating the network load balancer, we are going to use the Kubernetes object of type service, and also we are going to ensure that it is annotated for NLB. So we are going to add an annotation stating the network load balancer so that it can create the network load balancer for us. And when coming to the earlier version, which is AWS ALB Ingress controller, so it doesn't support latest Ingress API version, which is networking.k8s.io/v1. So from Kubernetes version 1.22 onwards. So in addition to that, this ALB Ingress controller will not have any developmental releases planned, and soon it will also get deprecated. So with that said, we need to use the latest and greatest available from Ingress perspective on AWS EKS cluster, which is AWS Load Balancer controller. And this supports latest and greatest from Ingress perspective. So this is the Ingress API which the latest load balancer controller supports. Now, the next thing here is how this load balancer controller, what are the objects involved from Kubernetes perspective for this load balancer controller. So let's see that in a visual manner. So if you see here in the EKS cluster, we have something called kube system namespace. And you can see in AWS cloud, other AWS services will be created here, and the core EKS cluster related resources, and inside that whatever it is going to get created as part of this load balancer controller or which is involved with that, we are going to depict them inside this kube system namespace because they are going to get created in this namespace. So to start with, the very important point here is AWS load balancer controller related service account in Kubernetes. And we'll create this service account, and also we'll create a IAM policy and then IAM role, and this IAM role will be annotated inside this service account. So this IAM role ARN will be annotated inside this load balancer controller service account. And why we are doing that, what it is going to provide us in detail when we are implementing practically, we'll know more in detail how we are going to do that. So on a visual manner, so these are the objects involved. You will have a IAM policy, you will have a IAM role, and that IAM role is annotated with a Kubernetes service account of type load balancer controller. So a load balancer controller service account will have an annotation of IAM role associated with it. And next thing here is, So whenever you deploy your load balancer controller, so it will create a deployment which eventually creates the pods related to this load balancer controller. And in addition to that, it will also create a load balancer controller webhook cluster IP service. And it will also create a AWS load balancer TLS related secret. So these are the things which are involved from Kubernetes perspective. In kube system namespace, so it will create a service account, it will create a load balancer controller deployment, it will create a load balancer controller webhook cluster IP service, and it will also create a AWS load balancer TLS service. So now this service account, whatever we have created, is associated with this deployment, which means it is also associated with the pods. So whenever this load balancer controller will get the ability, means like this load balancer controller gets the ability to create the application load balancers or network load balancers from EKS cluster in AWS cloud. So let's see that. So if you see here, in every EKS cluster or any Kubernetes cluster, we know that we'll have the Kubernetes API server. So as a Kubernetes administrator, so what I am going to do is, I'm going to, using the kubectl CLI, I'm going to deploy the Ingress K8s manifest. And this load balancer controller will watch for the Ingress events on this Kubernetes API server. And whenever it finds this Ingress K8s manifest is deployed, so this load balancer controller will take that manifest and go ahead and then create the application load balancer for us. So from AWS services perspective, you can see that as a application load balancer. And in Kubernetes, you can see that as a Ingress resource. So this is what is going to happen whenever we deploy a simple Ingress service manifest. Another important thing which we need to know here is this AWS load balancer controller deployment. So which means inside this deployment, we have the load balancer controller pods. So those are nothing but workloads in our EKS cluster. And those workloads are able to create a AWS service named AWS application load balancer from EKS cluster itself, right? So how it happened is based on the permissions whatever we have given for this load balancer controller. So we have created an IAM policy which has the permissions to create application load balancer related resources or update the resources or delete the resources related to application load balancer. And that IAM policy is associated with this IAM role. And this IAM role is annotated. This IAM role ARN is annotated with the AWS load balancer controller service account. And this service account is used by this load balancer controller deployment related pods. So due to that, from EKS cluster itself, we are able to create the AWS application load balancer whenever we have deployed the Ingress K8s manifest. So this completes the introductory part of AWS load balancer controller, and in our next lecture we are going to practically install it and then understand it in a better way. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. Let's go back to our GitHub repository now. So we are in AWS Stack Simplify / AWS EKS Kubernetes Masterclass internal repository, which is a private repository of mine. And whenever I do the course updates, so I will add the new section here and then update the sections in detail here, all the documentation related to that. And then when I am publishing, once everything related to that section is completed, so I will publish the videos on Udemy and also ensure that that equivalent section related Git changes also will be added here. So this is the public repository where you have the access, which is AWS EKS Kubernetes Masterclass. And currently inside this you have only 08 ELB. So there is nothing related to 08 new ELB. But now once this entire section recording is completed, so I will ensure that this respective section related all the changes are also added here and then you will get access to them. So for now the recording will happen on this internal repository and we'll move on to the section 0801 load balancer controller installer. So this is the first thing we are going to do as part of this mega section. And here So as part of step 00 introduction, we already understood what is load balancer controller and then how it is going to have the objects inside Kubernetes and then how it is going to create the application load balancer and all those things. So this is primarily on a high level. If you see it, we are going to create a IAM policy and make a note of that policy ARN, and then we are also going to create a IAM role and associate this IAM policy to this IAM role, and also we'll create a Kubernetes service account and bound this role and then service account together by annotating this service account with this role ARN. That is what we have seen in the picture here. So we'll create a IAM policy and that is associated to the IAM role here, and this IAM role related ARN will be annotated in the Kubernetes service account here. So let's come back here, and in addition to that, we are also going to install the AWS load balancer controller using the HELM 3 CLI, and also understand about the new concept introduced inside this AWS load balancer controller. So is Ingress class concept, and we are going to understand that, and also whatever the Ingress controller we are going to install, we are going to make that as the default one. So we'll see all those things in detail when we are implementing these steps, right? So for now, we'll move on to the prerequisite steps here. So we have 3 prerequisites which we are going to implement now. So the first prerequisite is ensure that you have the EKSCTL and then kubectl command line utility installed. So as part of the prerequisite section of this course, already they were installed, but we will cross check once, right? So we'll say EKSCTL and version. So as on today, this is the latest version, but whenever you are doing it, it might be a different version too. And also we'll see the kubectl and we'll say version and hyphen short, right? So it will provide the both the client version and also the server version. So the client version I'm using is v1.22.4 and the server version is 1.21.5. And if you see the note here, you must use a kubectl version that is within one minor version difference of your Amazon EKS cluster control plane. For example, if you are using the 1.20 kubectl client, so you can use the Kubernetes cluster of version 1.19, 1.20 and then 1.21. So this means that as our client version is 1.22, our server version supported here are 1.21, 1.22 and also 1.23. So now let's come back here and move to the next prerequisite. Next prerequisite is create your EKS cluster and worker nodes if not created. So we already created the EKS cluster as part of section 0102 and also as part of section 0701, which is nothing but we have created as part of this respective section a private node group. So if you see in 01, right, in section 0102 we have created the EKS cluster and also we have created a and associated a IAM OIDC provider. And after that, as part of section 0701 we have created a EKS private node group. So both things are completed now, which means we should already have the EKS cluster and EKS node groups in our private subnets. But it is an additional cross check whether those were present or not. And if those were not present, then you can go ahead and then directly execute this command and this command and this command, these 3 commands to create them immediately. And as those were already created, so now we'll go back to our EC2, which is our AWS management console, and verify that we have the 2 private node instances running in a node group, and we can go to EKS Elastic Kubernetes Service and also verify the same things here on a very high level, right? So we'll go to EKS cluster and EKS demo 1 cluster is up and running, whose Kubernetes version is 1.21 as on today. And if you see here, so let's wait for it. So 2 nodes are running there, and the current workloads you can see CodeDNS, AWS node and then kubeproxy. And the configuration information we can see here in detail. So this is what we have and then ready for us so that we can go ahead and then directly install the AWS Load Balancer Controller. So once the prerequisite 2 verification of these things were completed, so we'll go back here and also verify the same things using EKSCTL commands. So EKSCTL, and you will say get cluster, and you will find that EKS demo 1 cluster is up and running. See, EKS demo 1, and it is created using EKSCTL CLI. And we can get the node groups for this respective EKS demo 1 cluster. So let me copy this command and run it here and see the node group associated with this respective EKS demo 1 cluster. So you can see EKS demo 1 ng private 1 is the node group name, so which is already created, and it has currently 2 nodes running. And verify if any IAM service accounts present inside this EKS cluster. So let me see that too. So EKSCTL get IAM service account and provide the cluster name. So it will say that there are no IAM service accounts found inside this EKS cluster. Okay, fine. And another important thing here is, if you have not configured your kubectl kubeconfig, so whenever the EKS cluster is created, it will automatically get created, the kubeconfig, which is located in $home/.kube/config. So this will have the information. So I'll say cat, and this will have the information about connecting to our EKS cluster using kubectl, all the authentication information. And if by any chance whenever you run the command kubectl get nodes and you are not getting any output from this local desktop CLI, you are not able to connect to your remote EKS cluster instances in AWS cloud, and you are not getting this type of output, so then you can go ahead and then run this command AWS EKS, and in which region your cluster is created, and you can say update kubeconfig and provide the name of your cluster here. So my name of my cluster is EKS demo 1, which you can get using EKSCTL get cluster to get the cluster name, and then update your cluster name here and run this command. So what I'm going to do is, so I will empty my kubeconfig here, right? So I'll say .kube and config file. In .kube folder, I have the config file, and that I have cleared it. And if I say cat for that file, nothing is there. So now I will run this command, so that again it will reconfigure, or it has added the content there, and you can see all this is added. So before that, what I'm going to do is, so first I'll clear that, right? And then run the kubectl get nodes and then see what happens, right? So let me run the get nodes, and it says that connection to the server was refused because there is no configuration information for kubectl to connect to your AWS EKS cluster. So it has no information about to which EKS cluster this kubectl command need to connect and get the nodes information. So we'll run this command, which is AWS EKS region US East 1 update kubeconfig name EKS demo 1. And now we'll run the kubectl get nodes, and we'll get the information because our local config file has the information, connectivity information to our remote EKS cluster running on our AWS cloud. So this is good, and these are the prerequisites we need to cross check, which is you have your EKS cluster up and running, and you are able to connect it to using kubectl get nodes, so that your kubectl CLI is configured perfectly with that. So that's what we are supposed to verify, all these prerequisites. So in our next lecture, we are going to move on with creating the IAM policy. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. As part of step 2 and then step 3, we are going to create the IAM policy, IAM role, and also create a load balancer controller service account in Kubernetes and annotate that respective service account with this respective IAM role. So let's go back to our GitHub repository, and as part of step 2, we are going to create a IAM policy. So here, whatever we are going to create, we are going to take the latest version. So we'll go to our directory 08 new ELB application load balancers. So let's go to the terminal here and clear this. and we are in AWS EKS Kubernetes Masterclass internal. In my case, in your case, it is going to be AWS EKS Kubernetes Masterclass, and we'll go inside 08 new ELB application load balancers, and inside that we are going inside 0801 load balancer controller install. And inside this, if you see here, I already have the files IAM policy latest and IAM policy v231.json. So what I'm going to do is, whatever I have existing one, I'm going to remove this IAM policy latest one, and using this curl-o and IAM policy latest.json, and I'm going to download this policy from this location. So let me go here and copy this entire line, copy, and if you see here, already my IAM policy latest file was already removed as part of rm command. So I'll run this command curl-o IAM policy latest JSON. So it has downloaded the latest file here. So if I say lslrta, so you can find the IAM policy latest file. So you can review that directly in our Visual Studio Code here, and go to that 08 new ALB application load balancers, and inside 0801 load balancer controller install. So if you open this IAM latest policy.json, so you can find here in detail the policy related permissions, right? So all these are the things it is required for us. So there are a lot of permissions required for us, and all these are outlined here out of the box from AWS perspective. So now if we come back here, if you want to use any specific version, so the file name you need to create it is with that specific version, and you need to find this file with that specific version. So if you in Kubernetes 6, the repository name is AWS load balancer controller. So I'll go to github.com/ and I'll go to that load balancer controller, and if we come back here and in main docs install, right? So if you go to inside this folder, you will have something called docs folder, and inside docs folder in install folder, right? So in install folder you can find the IAM policy.json, which is the latest one, right? And you can use that one, or you can go for a specific version which is related to v2.3.1 or v2.3.2 etc. directly by specifying that version number here, and accordingly you can download that version. So we are going to use always latest, so that's the reason I have provided the latest means like the root repository related, main repository, main branch related information here. So you can see here, so main docs install IAM policy.json, which is referring to the latest file here, right? So now let's come back here, and we have successfully downloaded that respective file in this folder AWS 0801 load balancer controller install. And now we are going to do is, we are going to create a IAM policy, and policy name we are going to provide is AWS load balancer controller IAM policy, and the policy document we are going to reference from file : / and our file name which is in that respective current working directory. So we are going to create a policy using the AWS CLI command, AWS IAM create policy. So let me copy this and paste it here, and this should create the IAM policy for us. So it has created the IAM policy, and this is the ARN it has created for us. So we need to make a note of this ARN because we are going to reference that in upcoming sections. So for me, this is my AWS account ID, and remaining things are going to be same for you also. Your account ID usually will differ, but rest all is going to be same. So anyway, I'm going to copy this and come back here, and I'll say file, new file, and just save this ARN here for a while. Now let's come back, and we have successfully created the IAM policy. So let's in AWS services go to IAM service and search for this policy. So this is the policy we have created. So let me copy this policy name, and then go to policies and search for that policy, and you will find this policy which is a customer managed policy, and inside that all these are the information whatever it is going to provide, means like the access we are going to get as part of this policy, right? So now let's come back here, and if there are any errors also, we really don't need to worry, but just make a note of the policy ARN. That's good. So now in the next step, we are going to create a IAM role for the AWS load balancer controller and attach the role to the Kubernetes service account. So for this, we are going to use the EKS-CTL, right? So using EKS-CTL, we can do that. EKS-CTL directly have a command called create IAM service account. So which means it will create a service account in Kubernetes and also create a IAM role in AWS IAM service and associate the policy whatever we have created to that IAM role and take that IAM role's ARN and then annotate it in the Kubernetes service account. So all this with a single EKS-CTL command, we are going to do that. And we really don't need to worry about manually implementing all these things. So applicable only with EKS-CTL managed clusters, and our cluster we have created with EKS-CTL, and we are going to do successfully. How we are going to do it, we are going to see now. So this command line will create a AWS IAM role, yes, and associate the IAM policy whatever we have created, and also will create a Kubernetes service account in K8s cluster and also annotate this Kubernetes service account with the IAM role ARN. So now let's come back here and understand about that command. So before understanding about that command, so first verify in kubesystem namespace any service account with name AWS load balancer controller is present or not. So you can say here, come back here and say clear and kubectl get SCA. SCA is the alias name for service account, and say -n and kubesystem. In namespace kubesystem, we are verifying, we are listing all the service accounts, and on the top we will verify it will come in the alphabetical order, and on the top we will verify if there is anything with AWS load balancer controller. So with AWS you can see AWS cloud provider and AWS node, but nothing else is provided here. So anyway, if you want, you can provide the exact name and then also search. So we will search with this name and AWS load balancer controller, and it is saying that no service accounts with that name are found currently. Now let's come back here and understand this command, which is EKS-CTL create IAM service account. So for this command, we need to provide the cluster name, our EKS cluster name, which is EKS demo 1, and this service account in which namespace we need to provide, our Kubernetes service account, right? So in the namespace kubesystem we need to create, and name of my service account is going to be AWS load balancer controller, and the policy we are going to attach. Why? Because this create IAM service account is nothing but with IAM it is going to create a IAM role, and service account it is going to create a Kubernetes service account. So which means for this IAM role you are going to attach your policy ARN. So whatever the policy you have created in the previous step, so its ARN we need to provide here, right? And override existing service accounts is an additional tag, and if you want you can say approve, right? So this is the command we need to provide so that it will get created. So in my case the cluster name is EKS demo 1, and namespace it need to create for everyone, it is going to be kubesystem, and for you only if your cluster name is different, put it here, and name is AWS load balancer controller, which is my service account name, and attach policy ARN. So ARN whatever we have made a note as part of previous step, this is the one, right? So the same thing you need to provide here. For me it is not going to change because it's the same account ID, AWS account ID. In your case this account ID changes, right? Or whatever the note you have made for your IAM policy, so the same thing you can replace here. And finally you can take this command and run it. So let's come back here and run the command EKS-CTL create IAM service account. So let's wait for this command to execute, and it need to create. So it is going to create a CloudFormation stack for this. So we are going to see that. See, so creating IAM role for service account, and in kubesystem namespace it has created the AWS Load Balancer Controller service account, right? So it has created the service account, and it is also deploying the stack EKS-CTL EKS Demo 1 add-on IAM service account kube system load balancer controller. So this is the CloudFormation stack name. So it is deploying the CloudFormation stack, and inside that we'll have all the automation to create all these things and then associate it with the Kubernetes service account. So let's wait for this thing to get created. So we can see here created service account kube system / AWS load balancer controller. So let's come back here and verify using EKS-CTL CLI. So let's start with, we'll do multiple verifications. So let's do one after the other. So we'll say EKS-CTL get IAM service account and provide your cluster name, right? So -- cluster equal to EKS Demo 1. And if you remember earlier when we have run this command, we have got no IAM service accounts. But after running the previous command, it should have created one service account for us, right? So in the kube system namespace, the service account name is AWS Load Balancer Controller, and it is associated with the role ARN, whatever is created in AWS IAM service. So the role name is going to be EKS-CTL EKS Demo 1 add-on IAM service account kube role 1, and then some dynamic name generated here, right? And now, so let's come back here and verify the CloudFormation template EKS-CTL created and IAM role. So let's go here and go to CloudFormation service, or you can go to services and search, right? So I'll open a new window here. I'll say, I don't know, so for some, yeah, I got it. So let's go to the CloudFormation service here and let's verify the same thing. So we have the EKS-CTL EKS Demo 1 add-on IAM service account. So this is the stack name for us. So let's open it, and once we open it, right, go inside the resources tab and click on the link physical ID to open the IAM role. So inside this, if you go to the resources tab, so you can find only one resource is present here. This is the resource which is nothing but a IAM role. The type is a AWS IAM role. So if you click on this, and if you want, you can open in the new tab. It will open the IAM role created for us, right? So this is the IAM role created, and it is associated with the policy whatever we have created, AWS Load Balancer Controller IAM policy. It is associated with that, and you'll have the trust relations related to STS assume role with web identity and all these things. And now let's come back here, and this is the ARN of this role, ARN and then so and so, right? So now let's come back here and verify KITS service account using kubectl. Mainly you need to verify the annotation, right? So first we will get the service account, right, whether it is created or not. So we'll list all the things and verify whether it is present there or not. So you can see here AWS Load Balancer Controller is present there. So clear, and we will run the command get that respective service account, right? And we should see that that service account is present and which is created 3 minutes before, right? And now describe that service account, kubectl describe service account AWS Load Balancer Controller and -n kube system. So when we describe that service account, so we should see the annotations tab mainly. So let's see here, name of the service account is AWS Load Balancer Controller, and namespace is kube system, and labels you can see app Kubernetes IO managed by EKS-CTL, and in the annotations you can see eks.amazonaws.com/role ARN, and this is the role ARN it has been annotated with. So now let's come back here and search for that role ARN here, and you can see this is the same thing here. So that's the important thing. So now you can see that newly created role ARN is added in the annotations, confirming that AWS IAM role bound to Kubernetes service account, right? So this completes the creation of service account, IAM policy, IAM role, and annotating that IAM role ARN inside this Kubernetes service account. So in our next lecture, we are going to go ahead and then install the load balancer controller using HELM. So I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. As part of step 4, we are going to install the AWS load balancer controller using HELM. So let's come back to our PowerPoint presentation. And if you see here, already we have completed the part where we have created IAM policy, IAM role, and then service account, and then annotating that service account with IAM role. So now whatever we are seeing in this box, which is load balancer controller deployment, its equivalent secret, and also its cluster IP service, webhook cluster IP service. So these things we are going to deploy now, and using HELM we are going to do that. So let's come back here, and if you don't have HELM installed on your local desktop, so you can install the HELM using these commands, right? So brew install HELM if it is Mac OS, and if you want to use different operating system, so you can see here using HELM with Amazon EKS, and you can see here if it is Mac OS, use this command and brew install HELM. And if you are using Windows, so you can say Choco install Kubernetes HELM using Chocolatey. Or if you are using Linux, so you can directly download the respective binary, and then using gethelm.sh script, you can install it. So now let's come back here and install it using brew install HELM, because we are using the Mac OS here, right? So I'll say brew install, and then I will say HELM, and it will download the HELM and then install for us. So let's wait for it to install. So we can see here HELM was successfully installed. So maybe it is 3.8.0 version. So let's see what exactly it is. So I'll say HELM, and then I'll say version, and we see that v3.8.0 is installed for us, right? So now as part of step 0402, install AWS load balancer controller. So before installing that using HELM, we need to understand about two important notes here. So the one important note here is, if you are deploying the load balancer controller to Amazon EC2 nodes that have restricted access to Amazon Instance Metadata Service, which is IMDS service, or if you are deploying these load balancer controller to Fargate, then add the following flags. So using the HELM, tell the package that you are using the region code so and so, and then VPC ID where you are going to deploy it. So these two things it is asking us to set in our HELM command here. So if you are going to use with on restricted EC2 nodes where you don't have access to IMDS service, or if you are using Fargate. So instead of worrying about this note, so I made a standardization that in our command we are anyway going to use this, right? And next thing is, if you are deploying to any region other than US West 2, then add the following flag to the command that you run, which is image repository, replacing account and region code with the values for your region listed in Amazon EKS add-on container image addresses. So this is nothing but if you are using in different regions other than US West 2, so you need to provide your ECR endpoint, which is nothing but Elastic Container Registry endpoint from that respective region, so that it can download the AWS load balancer controller from that respective region only. So example, if currently our EKS cluster is in US East 1. So if you see this, get region code and then account info from here. So let me open this, let me close this, and you can see here. So these are the information. So for US East 1, this is the endpoint, right? So that is what we need to provide. So this is the account information you need to provide here, and region code you need to provide here. So this is the value you need to get. So this is the account, and US East 1 is the region code for US East 1 location. So I have provided the link here for getting the region code and account info. So get those information and provide the account ID and then region code here, and rest all is going to be same, which is Amazon AWS load balancer controller, Amazon AWS.com. So from here everything is going to be same for you also. So based on the region whatever you are using, provide that region here, which is US East 1 or US East 2 or anything, and also account ID you can get from this respective link whatever is provided here. So US East 1, so this is the value. So we'll see that when we replace down there. Okay, so now the first thing is add the EKS charts repository. So Helm repo add this EKS charts repository. So let me copy this and come back here and clear and add the command. So EKS already exists with the same configuration because I might have run earlier also, right? So it has added, and I'll run the command Helm repo update. So it is trying to get the updates for Ingress, Nginx, EKS, Jetstack, Stable, Bitnami, whatever is available in my existing local repo. It is trying to update all those things. So now let's come back here, and as part of this command we are going to install the AWS load balancer controller. So let's see this command breakdown and then understand in detail. So Helm install and AWS load balancer controller. So from repo EKS/AWS load balancer controller, and this need to be installed on -n cube system namespace, and provide your set. These are the set commands where you will provide the values for your respective package whatever you are going to deploy. So now set cluster name. So our cluster name is going to be EKS demo 1, and service account create. So during the Helm install itself you want to create the service account AWS load balancer controller? No. Why? Because it was already created earlier, and then now we don't need to create it. As part of previous steps we have already done that. So which means service account create is false. And what is the service account name we have created, which is AWS load balancer controller, which we have done as part of previous steps. So that is good. And region and VPC ID we need to set. So region code is US East 1. So you can see here, right? And VPC ID, so we are going to get now where our AWS EKS related VPC created for this cluster. And image repository, as we said, we need to get that from the region code and account ID in which your EKS cluster is created, which is 602.401 some 43452. So this is the account ID, and US East 1 is the region. So the same thing you can find it here. So now let me take this complete command and copy this command and come back here, and here let's paste this command and ensure that all the things are same for us. EKS demo 1 is the cluster name, and service account name is AWS-load-balancer-controller, and region where our EKS cluster is there is US East 1. So we only need to change the VPC ID. So this one also we have verified. US East 1 is the region, and account ID also matched. So now let's come back here and go to VPC, and in VPC go to that respective EKS demo 1 related VPC. So VPCs, and I should have default, and another one is EKS CTL EKS demo 1 cluster VPC, and this is the VPC ID. So let me copy this, or let me go here and copy from here and provide the VPC ID. So now let's copy this command and run it, right? So let's come back here and clear and run the command now. And once the command successfully completes, so we are going to see the output as like this: name AWS load balancer controller, and last deployed, and in which namespace it is deployed, status is deployed, revision is 1, and test suite none, and what it has installed is AWS load balancer controller installed. So let's wait for it to complete. So we can see here our AWS load balancer controller is successfully installed. So in our next lecture we are going to go ahead and verify what it has installed in a step-by-step manner. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. As part of step 0403, we are going to verify that our load balancer controller is installed, and also its equivalent webhook service is also got created. So let's start with whether the controller is installed or not. So we'll say kubectl-n kubesystem and get the deployments in our EKS cluster, right? So in kubesystem namespace, so we'll say kubectl-n kubesystem and get, and we can say deploy. So what all deployments available in kubesystem namespace, it is going to list for us. So you can see AWS load balancer controller, which was created 2 minutes before, right? So now if you want to also see in detail, right, if you want to describe the deployment and review it, so we can describe it, right? So this is the name of the deployment, right? So copy and paste, and instead of get command we'll use the describe command here, right? So I'll say describe, and you should see that the entire information about this is going to be provided in detail. See, name of the deployment is AWS load balancer controller. In namespace kubesystem it was created, and these are some of the labels of it, and the version it has installed as on today latest is v2.3.1. So it has installed the 2.3.1 and it has done using, so labels are the very important thing. So how it has installed also you will know. So it is managed by HELM here, right? So instance name is AWS load balancer controller, and name also you can see AWS load balancer controller, and it is managed by HELM, and version also you are going to see 2.3.1, and HELM chart version you can see 1.3.3. This is the HELM chart version, and this is the EKS load balancer controller version is v2.3.1. So both are different. And now annotations, you can see deployment and meta HELM, some additional things whatever they have defined here, right? And another important thing you can see here is in the selector labels you can see app Kubernetes IO instance and also app Kubernetes IO name, and both have the AWS load balancer controller. So, and in addition to that, replicas, it has created 2 desired replicas, and strategy type, deployment strategy type it is using is rolling updates, and rolling update strategy also it is saying 25% max unavailable and 25% max surge. So, and this is the pod template, and if you see here, this is the very important point where you can see service account it is going to be associated with is AWS load balancer controller. And containers it has downloaded from the image repository whatever you have set, right? And ports it is using is 9443 and then 8080, right? And the cluster name is EKS demo 1, whatever the arguments you have provided. Ingress class ALB, AWS region code is this one, AWS VPC ID is whatever you have provided. It also internally have the liveness probe whatever they have defined inside the package, and it has the volumes, and it has some certificate mounted to it whose name is AWS load balancer TLS. So this one just remember it. Why? Because if you see here AWS load balancer TLS, so that is what is mounted here. So this is the secret which is mounted as volumes here. Why? Because this respective load balancer controller listens on port 9443. So the communication to this load balancer controller is going to be on SSL, and it needs a TLS certificate associated with that, and that TLS certificate is associated here as volumes inside that using a secret, which means when you go and then verify that secret, we'll find that one also. And you can see the events, normal, scaling, replica set, everything looks good. There is no errors or anything from events perspective. So this is about the deployment, right? And now we'll also verify the service here, which is webhook service. So kubectl-n kubesystem, and then instead of deployment, so I'll say clear, and instead of deploy, right? So we are going to say SVC. So we'll get the services in the kubesystem namespace, and you will see kubedns is one service, and AWS load balancer webhook service is one more service, and which is listening on port 443, right? And here you have seen the port 9443. So now we'll see the important things here. So this is 9443, and the selector labels inside this, right? The selector labels inside this is also you have seen here, right? The selector labels is instance AWS load balancer controller and name and AWS load balancer controller. So these are the selector match labels should be available inside the service labels, right? Service selector, so that traffic coming to this 443 port need to be sent to that 9443 port. Those also we need to verify for our additional understanding only. So whatever we are discussing is for our additional understanding and dissecting each of the objects and then seeing the internals of it. So let's come back here and see verify labels in service and selector labels in deployment, right? So this is the webhook service which you are going to output using YAML, right? So what is this? So get SVC and load balancer webhook service with YAML, and inside this you go to selector and you see these two are the values inside the service selector, right? App Kubernetes IO instance and app Kubernetes IO name. And now verify the selector labels in our AWS load balancer controller deployment, right? And you'll find here also, come back here and you'll find the selector match labels and you can see the same thing. Whatever you are seeing in selector match labels of the deployment, same you are seeing in the service here. So that very clearly tells us that whatever the traffic coming to the webhook service on 443, it is sending to our deployment, AWS load balancer controller deployment. But let's also verify this one more time on which ports it is sending, right? So that's also very important. See, so the port it is using is 443, which is the front end port for this respective cluster IP service is 443, and the target port it is sending is webhook server port. So this webhook server port is nothing but 9443 port. So let's come back here, right, and verify that, right? So these are the container ports, and in container ports you can see container port 9443 whose name is webhook server, right? And the other 8080 port for this load balancer controller is a metric server port. So this is very important. So for the webhook service is listening, the cluster IP service is listening on 443, and whatever the traffic comes to that webhook service, it is going to send to AWS load balancer controller pods, whatever for the deployment, whatever the pods created for those pods on port 9443, right? Means like this container AWS load balancer controller container is listening on 9443. So good. So this clears out one important thing, which is webhook service and also the AWS load balancer controller, how the communication is happening in between them also. We got a complete picture. So in our next lecture, we are going to verify additional logs and additional stuff. So I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. In this step, let's verify the load balancer controller logs. So we'll list the pods from the kube system namespace and we will verify the pods. So let's come back here and clear this and say kubectl and -n kube system namespace and get pods. And we have two pods running here related to load balancer controller, and those will be listed here. AWS load balancer controller 2 pods, and we can copy this pod name and say kubectl -n kube system and logs -f and provide the pod name here, and we can see the logs of that respective pod, and all seems to be shown as info, so which very clearly says that we don't have any issues. But if we have any issues or any errors it has been showing, so we can see in detail, right? So but currently it is only a info things which we really don't need to worry. And if we want to see for other pod also, so the same command applies for us, which is provide the kubectl -n kube system logs -f and the pod name, the second pod name. And now till here everything is completed related to load balancer controller, right? But for additional verification and then for additional understanding, step 0405 and 0406 are defined, and these are completely optional, and those were highlighted with internals to understand more about it. So if you want to move on, skip this and then move on to next step or next video, you can move on. Or if you want to see about what is present internally, we can also see these things. So this is about AWS Load Balancer Controller Kubernetes Service Account internals. So this is the service account. So we will list that out in a YAML format. So let me clear this and let's wait for the service account to be displayed in YAML format. So API version is v1, kind is service account, and annotation, we know that our role ARN is outlined here, and this is managed by EKS CTL because we created this using EKS CTL IAM service account command, create IAM service account command. And now if you see here, name is AWS Load Balancer Controller, this service account name and namespace. Additionally, it has something called secrets. So API version, kind, metadata, and secrets, right? So inside this secrets, you have something called AWS Load Balancer Controller token. So this is the important thing which we need to be worried about. So get secret and get the value from there, and then -o YAML. So I'll say kubectl -n kubesystem, right? And I'll say get secret, and this is the secret name. So we need to take it from here, copy, and we will provide -o YAML so that we'll get the secret in a YAML format, right? So let's run that, and you can see you have lot of information inside this secret. So secret, and you have the CA-cert and also the token. So the token, what is this token? So that's the important thing here. So if you want, so you can use SSL checker cert decoder to decode the cert. First thing is we'll go to base64 decode, right? So we'll first deal with ca.cert, whatever is present inside this secret. So this is ca.cert and this is the value. So let me copy it and paste it here and then decode. So you got the certificate information here. And this certification information, so we will decode one more time using SSL checker cert decoder. So we'll go to that browser and take the base64 decoded value from here and go to the certificate decoder and decode it, right? And you'll find here, so this is issued on so and so date and expires on so and so date, and common name is Kubernetes and common name is Kubernetes. So this is a standard CA-cert present inside this. So this is CN is equal to Kubernetes. So you can see the entire information here. So that is fine. So that is not the big thing here. So inside the secret, you have something called token. That is the important thing which we need to see. So first things first is we'll close these things, and one more time we'll open the base64 decoder, and also we'll open the jwt.io and put them aside and go back to our secret here, right? And inside secret in the token, whatever is there in the token field, you are going to copy that value. So whenever you have outputted your secret in a YAML format, you got all this information, right? So you are taking this copy of this token and you are going to do a base64 decode and take that information, right? And go here and put it in the JWT encoded field, and then you'll get the decoding of that respective JWT token. So you can see here Kubernetes service account, namespace in kube system, and secret name is so and so, and all the information metadata about it. It is used by AWS Load Balancer Controller. So why I am showing this JWT, right? So this Load Balancer Controller, right, is creating this AWS application load balancer whenever the Ingress manifest, right, here is deployed, and when the K8s API server gets that information, this load balancer controller watches for Ingress events, takes that, and then creates this AWS load balancer controller. So but what is the authentication mechanism between this EKS cluster and AWS services? So if you want to call any AWS API, right, any AWS API, here this load balancer controller is going to call the application load balancer APIs and then create that respective load balancer controller. To call that API, it needs to have the authentication mechanism, right? So that authentication mechanism, how it is defined in between these things, is this respective JWT token. So on a very high level, if you want to understand the APIs, the AWS service related APIs are like service APIs you can call, and the identity provider here is going to be your EKS cluster, which is added as identity providers in your IAM, right? So as part of 0102 section itself, so we have added that. So if you go here and let me go here, right, and go to the AWS EKS Kubernetes masterclass and go to the section 01 and go to 0102 here. And if you see the step here, create and associate IAM OIDC provider for our EKS cluster, right? So let's understand that in a high level. We are not going super deep here, but let's try to understand in a high level that this respective EKS cluster is added as a identity provider for the IAM service here. See, so whatever we have done, whatever we have run this command, right, EKS utils associate IAM OIDC provider. So at that point of time, our EKS cluster is added here as a identity provider. So which means the identities present inside our EKS cluster will be able to access the AWS services based on the role assigned to the identity inside Kubernetes cluster. And inside Kubernetes cluster, the identity is nothing but the AWS load balancer controller service account. So if you come back here, so the identity inside the EKS cluster is AWS load balancer controller service account, and this is annotated with the IAM role here, which has the permissions defined in this IAM policy. Based on those IAM policies, this service account, whatever is created, this load balancer controller will use, and whatever the token generated, right, using the token, it can authenticate against the services whatever is allowed as part of this IAM policy, and then create, update and delete those application load balancers. So this much linking is present inside this internally. So we can go still deep and then see how this IAM OIDC provider related pictures and all those things, but for now it becomes super advanced and then we get confused with what we are going to learn about the Ingress. But I just want to ensure that in the internals of these things, so how this AWS load balancer controller deployment related pods is able to create this AWS application load balancer. Without any authentication, it's not possible, right? So it need to have some authentication mechanism. So that authentication mechanism is nothing but here whatever the token you are seeing. So using this token, it will be able to authenticate to those respective APIs and then create the application load balancer for us. So now let's come back here, and where are we? So this is the one, right? So we have seen these things, and if you see in the deployment also we have seen the service account, and in pods also we will find the service account, right? So if you go there and you'll find something called in the volumes also, you'll find the AWS IAM token. All these things you can see in detail if you run this command, right? So if you say kubectl get pods, already for the deployment you have seen the service account name AWS load balancer controller. But for the load balancer controller pod spec, if you review, you will understand more and more here. So we can take these things and say kube system, and this is the pod name we want, right? So copy, and this is the pod name, right? So copy this pod name and -o YAML, and then you'll get the complete pod specification here, and inside that spec.volumes.name. So if you go and then verify the volumes here, right, in the you will find something called this respective pod spec volumes. So you are going to find this one, service account token, audience is sts amazon aws.com, and if the path is going to be token, and it is going to be the name of the token is going to be AWS IAM token. So let's find those things. So we'll copy this to our something like our any of the file here and then search it. So let me copy and come back to the Visual Studio Code here, remove these things, and now remove the first line here whatever we have added, and come down and remove the last line Kalyan MacBook Pro, and search for AWS-IAM-token, right? And you will find inside the pods, pod spec volumes, AWS IAM token, and which is using the token here, and this path is token. So now let's search for those things. So you can see in the volume mounts, you will find the mount path AWS IAM token, and in our EC2 instances, in where run secrets in so and so location in service account, you will find this IAM token. And in addition to that, we'll also find token here, token, and we need to find here AWS. This is the environment file, web identity token file, and in service account, this is the path, token path here, value, right? So this path we are picking here in detail. So let's come back here. So spec volume name, we have verified this, and we'll go to volume mounts, and we have verified this, and in web identity token also you have find. So all these things, if we put them together, you will understand how the values are mounted to your pod inside load balancer controller, so that the application present inside that load balancer controller, which is load balancer controller application, is able to authenticate against AWS APIs. We can understand in detail, but these are only for our internals understanding how things are mounted and all those things. So in addition to that, you have something called Verify TLS certs for AWS load balancer controller. So these are the TLS certs which we have seen earlier. So whatever this token, whatever you have seen is directly related to your load balancer controller, right? So which means like for your load balancer controller related service account, the secret mounted to it, that one we have seen as part of step 0405, right? But when you go to step 0406, you will find something called Verify TLS certs for AWS load balancer controller. So this is the one we are discussing now, AWS load balancer TLS. So this is the secret. So we have the 9443 port, which is a SSL port running here. So for that, the certificates you are going to take from this AWS load balancer TLS secrets. So you can go here and then get the output of this kubectl-n kube system, get that secret, which is AWS load balancer TLS, and you will find the TLS key and then TLS certificate. So we'll take the certificate and then decode it and then understand in detail. So let me copy it here and go here and remove this and paste it here and then decode. So no, let me remove this. I'll just say base64 decode. Let me close these things, and this is the certificate, and I'll say decode, and you got the certificate here, copy, and I'll say SSL checker cert decoder and decode this certificate, and you will find something here. The common name of this certificate is AWS load balancer controller. So the webhook service, right, is listening on 443, and load balancer controller is listening on 9443, and these needs these certificates, right? And the SAN certificate names for these things: AWS load balancer webhook service.kubesystem and AWS load balancer webhook service.kubesystem.svc. So these are the additional SAN names available for this respective certificate. So that's it. So this is another additional information which we need to understand about port 443 and then port 9443 for service and pods for the AWS load balancer controller. So if we open it and then see it in detail, if you want to go to that load balancer controller pod and go to the volume mounts and verify the mount path for serving certs there, and also verify the volumes, you will get the additional understanding about those pods. We really don't need to worry or go in this deep for this respective things, but for additional understanding, it is always good to know more, right? So that's the reason this 0405 is always optional for you, but I have put them for additional understanding. So I'll see you in the next lecture. Until then, bye bye. Thank you. So before going to next lecture, so this is step 0407, which will help us in uninstalling the AWS load balancer controller. HELM uninstall AWS load balancer controller from namespace kube system. So this is optional. We are not going to use it, but just for additional reference, I have put it here. So I'll see you in the next lecture and discuss about the Ingress class concept. Until then, Bye bye. Thank you. Welcome back. Step 0407, uninstall AWS load balancer controller using HELM command. So this command is put here for information purpose only. So we should not execute this command. So this command will uninstall the load balancer controller whatever you have installed as part of previous step. So this is just to know that how to uninstall our load balancer controller using HELM uninstall command. So for that purpose, for information purpose only, this step is put here. Welcome back. As part of step 05, we are going to understand about the Ingress class concept in Ingress controllers. So if we go back to our PowerPoint presentation here, and let's understand the problem scenario here and where the Ingress class comes into the picture. So if we have multiple Ingress controllers running in our Kubernetes cluster, how to identify to which Ingress controller our Ingress resource or service should be associated to. So if you take your Kubernetes cluster, you have EKS ALB related load balancer Ingress controller installed on your Kubernetes cluster, and also you are running the Nginx Ingress controller, and you are also running the AKS application gateway Ingress controller. So assume like this, multiple Ingress controllers are running in our Kubernetes cluster, and you have deployed your Ingress resource using kubectl, right, or Ingress service, and that Ingress service should be associated to which Ingress controller. So that there comes the concept called Kubernetes object type or Kubernetes object of kind Ingress class. And not only these three Ingress controllers, so if you see here, there are many Ingress controllers available in the market as on today from Kubernetes perspective. So to identify and associate your respective Kubernetes Ingress service to a Ingress controller, we use the concept called Ingress class. So this is the high level definition of the Ingress class we are going to define, so that it is going to associate it to our ALB Ingress controller. So if you see here, standard Kubernetes YAML manifest format, API version, kind, metadata, and then spec. And API version for ingresses, we are going to use networking.k8s.io/v1. So earlier in the ALB 1.1 version, we are using a different version which is not supported in the latest Kubernetes versions, and now the supported version is going to be this one, the API version, networking.k8s.io/v1. In fact, this is the reason why we are redoing this entire use case here. In addition to also the new version of AWS load balancer controller also introduced. And you can see here the kind is Ingress class, and metadata we have the name and annotations, and in name we have provided the name as my AWS Ingress class, and annotations will come back to it later. And in the spec, this is the important part, you have the controller and you are defining the controller as ingress.k8s.aws/ALB. So here use this Ingress class, right? So whatever the Ingress class you are deploying, so this is tied to your controller, which is nothing but your AWS ALB Ingress controller. And whenever in the Ingress service you use this name, Ingress class name, whatever it is, my AWS Ingress class, so which means that Ingress service will be associated to this respective controller, which is AWS ALB Ingress controller. So now let's come back to this annotation, ingress class.kubernetes.io/is default class and then true. So what exactly this does? So let's see in the next slide about that. So you have a Ingress class, right? And you have a Ingress resource. So we are going to do a Ingress resource by live template writing in upcoming sections, but this is just to understand. Ingress resource is nothing but it's like you are going to create the application load balancer using the Kubernetes manifest. So on a high level, I will explain it here, and in upcoming sections, in the next section, which is Ingress basics, we are going to do the live template writing for this respective resource. Here the point we are trying to understand is about the is default class equal to true or not. So this is the API version networking k8s.io/v1, and kind is Ingress. So you can see here, this is the Ingress class and this is the Ingress, and metadata and name you can see Ingress Nginx app1. So this is the Ingress service you are going to create, and we'll leave the labels, it's a standard one. So we'll go to annotations, and you can see here ALB Ingress Kubernetes.io, and load balancer name you are giving app1 Ingress, and also scheme you are saying that this Ingress service should be created at the internet facing. So which means this creates the application load balancer in AWS as a internet facing load balancer. So here comes the API version, kind, metadata, and then spec. In spec, before going to this Ingress class name, also review this default backend. So this default backend has a service and whose name is app1 Nginx node port service, and this node port service will be with listening on port 80. So which means this application load balancer will have a default backend which will send the traffic to the Kubernetes service of type node port, and inside this node port you will have a selector labels which will be pointing to your deployment, Kubernetes deployment, where you will have the app1 Nginx deployment. The functioning of Ingress service or resource is not the core concept here. Important thing here is, so let's understand this. So you see the name of your Ingress class is my AWS Ingress class, and inside this Ingress resource you are saying the Ingress class name is my AWS Ingress class. So if Ingress class is not defined as is default class equal to true, then in Ingress resource, right, we need to define the spec.ingress class name, whatever you want to specify, so that this resource will be directly associated with the Ingress controller, which is nothing but AWS ALB Ingress controller. So now here comes the point. So if we enable these two lines, annotations, and then say this as the default Ingress, right? So which means you are saying AWS ALB controller as the default Ingress in your Kubernetes cluster. So at that point of time, this value which is Ingress class name, whatever you are defining here, you really don't need to define, you can comment it. So how many number of Ingress resources or services you are going to deploy, all will be associated with the Ingress controller which is defined as the default in your Kubernetes cluster. So this completes the high level introduction about Ingress class, and in our next lecture we are going to practically implement this. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. As part of step 06, we are going to review the Ingress class Kubernetes manifest which is present in 0801 load balancer controller install, and inside that you have the kube manifest folder, and inside that you have the 01 ingress class resource.yaml. So let's go to our Visual Studio Code here and go to 08 new ELB application load balancers, and inside that 0801 load balancer controller install, and inside that you'll find something called kube manifest folder, and there you will find the 01 ingress class resource.yaml. And we already discussed about this in the presentation also, API version, kind, metadata, and then spec. And here the API version is going to be networking.k8s.io/v1, and kind is Ingress class, and name of my Ingress class is my AWS Ingress class. And in spec you will have something called controller, and you will define your controller name as, or you will define the controller, this respective Ingress class you are going to tie with is the AWS ALB Ingress controller, which is nothing but our AWS load balancer controller, you can say. And you also define the annotation ingress class.kubernetes.io/is default class true, so that any Ingress services deployed inside this Kubernetes cluster will be associated with the AWS load balancer controller, whatever you have installed in the previous steps. So that's another important thing to know. So now let's come back here and deploy this Ingress resource. So we'll say kubectl apply hyphen kube manifest, so that anything present inside this kube manifest folder will be deployed. So let's come back to our terminal here. We are in 0801 load balancer controller install, and we'll say kubectl apply -f and kube manifest / and this should create the Ingress class for us. So let's wait for the Ingress class to get created. So we can see Ingress class got created with name my AWS Ingress class. So now we are going to get the Ingress class and also describe the Ingress class. So kubectl get Ingress class, and we should see that my AWS Ingress class got created successfully here 16 seconds before. And we'll also say describe Ingress class, and its name is my AWS Ingress class. kubectl describe Ingress class and my AWS Ingress class, and you can see name and annotation whatever you have specified, and controller whatever it has, and events as a nothing here. So this completes the creation of or installation of or setup of AWS load balancer controller on EKS cluster, and also creating the Ingress class for and making it as the default Ingress class, a default Ingress controller for our Kubernetes using the Ingress class concept. So I'll see you in the next lecture or in the next section with Ingress basics. Until then, bye bye. Thank you.